Hi, everybody. Welcome to Water Talks with InfoWorks. Let's see if I can advance my screen. I'm one of your hosts today. I always put this slide together in ranked order of importance. So I'm at the bottom, Sean Ingram. I am the systems engineer. I work in the Northeast region, and with me today is Nathan Gertz. Nathan.
Morning, everybody.
You got a little banged up.
Oh yeah,
Yeah.
This is
over the weekend.
a recent battle wound. I made the mistake of laying down on the floor with my eyes closed around my 2-year-old, and she decided to drop her large Play-Doh candy making set on my face. So yeah. Fortunately, no stitches yet, but I'm hoping this is a good lesson for her before we have our baby sister on the way. Yeah. Human lives are fragile. The 2-year-old.
So a lot of you have probably attended these before. Before we get into our topic, I just have a couple announcements. Recently, I don't know if you guys follow any of our newsletters or our event announcements on our website, but InfoWorks recently launched our learning management system. So this is a location on our website. So if you go to our InfoWorks website and click on Learning Center, it's going to take you to this page. And this has got a lot of educational resources. So some ranging from some quick how-tos to you can sign up for instructor-led courses. So a lot of great resources here on this website. Another thing we've recently launched is our e-commerce site. So on our e-commerce site, this doesn't have all of the products that InfoWorks sells, but if you just have some quick one-offs that you have for your project needs, so you work at a consultant and you just need an extra license, this is where you can go and don't necessarily have to get in touch with your InfoWorks regional sales manager or SE or ISR. I think so you can pay with a credit card for licenses here, and I think it's up to $20,000 for a license. I think that's the limit. So you can find some of our smaller linked licenses. I was looking at the water distribution licenses that were available here, and I think for InfoWater Pro, you could buy a license up to 3,000 links here on this website, and all you have to do is pop in your credit card information and we can send off that license for you. Another big thing that we announced recently, and we just last week had our big annual kickoff meeting. InfoWorks did. This was an internal thing, and main thing we talked about product-wise was Info360.com. And Info360.com is kind of our next iteration of our operational analytics and modeling tools that are going to be offered as a SaaS solution. So right now we have Info360.com released as a beta, and we have a few consultants. And do we have a utility testing it, or is it just consultants?
Yeah, utilities.
Okay. Yeah. So if any of you all have seen some of our presentations on old SCADAWatch or Info360, that's our on-prem solution, this is kind of the next generation. It's going to tie all of our tools in. So the kind of the first releases as it's coming out are going to be looking at asset management. And also, what is the
insights?
Other?
Yeah, insights helps with like pipe break simulations, as well as data analytics, leakage detection, things like that.
So initially, it's not going to be as robust necessarily as Info360 on-prem is, but this is the path for InfoWorks moving forward. Should also talk about some upcoming Water Talks topics. So you all know where to find these on our website, the registration page, and we also pummel you over the head with registration pages as well. But so next week we have a case study. This is going to be presented by one of our clients, Jason Kuntz from AECOM, talking about unidirectional flushing. Then on February 2nd, IoT 4.0. So that's going to be talking about Info360.com and Imagine. So the Innovyze utility platform for operational analytics with AI and ML. And then on February 9th, Nathan is going to be back to talk about tips and tricks for Ruby scripting. Do you have anything to add there, Nathan?
Yeah. Our a couple weeks ago we did tips and tricks on SQL query scripting, and I'll be probably touching on more of that even in the demo today. But there was a lot of requests for Ruby scripting, and we got kind of a legend in the industry, Luke Butler. He's been developing his own tools, and he's a solid hydraulic modeler, so he's kind of a rare breed of combining modeler and developer, and he has a ton of stuff on GitHub. So I'm really excited to get him out there to show free scripts that you can start using today with Ruby scripting. And that applies to WS, ICM, and Info Asset Manager.
Cool. The last thing before we get into today's topic is an upcoming virtual water tech forum. So this is, if any of you have attended some of our user group meetings, usually regional user group meetings, most of our regions usually host one or two a year. But since everything is moving online this year, myself and my counterpart Keith Hodgson are hosting a virtual meeting on March 23rd, and that registration page is up. Please sign up. You're all welcome. I'm still putting together an itinerary and an agenda for that meeting, but we're just about wrapped up, and I should be able to publish that, if not later this week, then early next week. So looking forward to that. I'll also be at NUIA next week if anybody's going to be attending that. I'll have a virtual booth there. Today's topic, episode 51, already 51. We started these as an SE team as a way to just keep our users engaged, and we really appreciate everybody continuing to show up. And we continue to have really great attendance. We have 71 people in the room already right now. So I think they've been well received, and we really appreciate your feedback and for you to give us your time. Today we're going to be talking about using ICM as a database to store your SWMM models. And anyone who hasn't attended before, this is how it works. Nathan has prepared a short presentation. He's going to be talking about storing those ICM models, and you can ask your questions in the questions box, and I'm going to be monitoring those and passing those along to Nathan as the expert to answer. And if anybody, this is something that I have played with sometimes, but sometimes people like to answer the question with their microphone. If you would like to, let me know in that questions box, and I can turn your microphone on, and we can have a little chat about it live. With that, I'm going to turn the presenter back over to you, Nathan.
Okay. Let me show my screen, and it's probably going to opt for the wrong screen. Let's go with
those.
This one.
So the upcoming water talks, we are a little bit delayed with getting those listed on the website, but I'll make sure that those are listed for the beyond next week. I don't think any others are listed, so I'll make sure that those registration pages are up by the end of this week. So stay tuned.
Yeah, just addressing a couple questions already in the chat. Those two water talks, they will be coming onto the webpage. Looked like someone was expecting to see those in the Learning Center. I think currently, if you do go to the Learning Center that Sean mentioned, there's currently like 10 courses, but that we are just now introducing it. And I know that our client success team they have a lot more courses that they're working on right now. So you'll see that library of online courses continue to grow quite a bit, especially I think the first half of this year. And it's free for a limited time. So go ahead and check it out. All right, well, I will jump into a few things. For those who love PowerPoint, I guess this is a little bit of a warning to talk about what I'm going to do in the next 30 minutes, but I'm just going to walk through some of my discussion points in PowerPoint first for about 10 minutes, 10 minutes of slides. I don't want to put you through too much, and then I'm going to show things in the software. And in particular, some GIS updates, scenario management, and really I want to show that you can do a round trip from ICM to EPA SWM and then back into ICM. That's one thing I want to tackle today, because I've seen that come up as a request from users, as well as a time series integration and Q&A. So let's jump into some PowerPoint. One thing first, for those of you who don't know, InfoWorks ICM, it has a 20-year history from having a proprietary engine that is, in my humble view, the best engine, of course. But you couldn't use an open standard EPA SWM model within ICM. You have to convert it. So just a year or so ago, we added a SWM engine inside of ICM. So that means, now the way how you can do that is you can have your ICM network and a SWM network, different copy of the data that uses a different schema, different sets of data. I'll show that, but you can actually do both, all mixed within ICM. And so ICM can be your hub for your ICM models and SWM models. You can convert and compare as needed. So just so you know, that's up there. This topic is targeted a little bit toward SWM users. ICM users will possibly likely learn maybe a few things, tips and tricks for data management, but ICM users have been, they've had access to a lot of these tools, whereas SWM users, I've even talked to larger municipalities with many, multiple modelers, but they're using, EPA SWM, InfoSWM, or even like PC SWM or something. And we've been talking to them about even letting ICM be a central database where they can still use their other SWM platforms for all the other users, because admittedly, ICM is not the most affordable tool compared to other SWM engines. But other SWM tools do kind of leave you with this headache of how do you manage versions and various copies, various scenarios. And so just sometimes the data management can be a little bit of a headache. And so ICM can sit in the center as kind of a central hub database, and you can then have viewer licenses and so on. So that's a little bit of what this topic is about. And I'm going to start through talking a couple slides. And I apologize if you've seen these slides before. I tend to talk through this, at least in a lot of my conversations with clients. But traditional model data management kind of looks like this in a lot of cases, where you might have a master copy of a model on a server. And then let's say John needs to create a new scenario of that for new loading in a portion of the network. So he pulls a copy of that. And then let's say Susan then looks at permitting of a new development. And so John made some updates. So she gets a copy from him, but then she makes some updates herself. Then John realizes he wants to look at an alternative approach to adding this new, new sewer loading in. But then Susan realizes she maybe wants to upsize a pump, and then various steps of data cleanup has happened at these different iterations. And how do you merge those? Because some is valuable, but some is project specific, so some you don't want. And it just starts to become a headache. At the end of the day, what are the changes you want to keep and archive back to your master copy versus what was just local one-off projects. And a year later, you can just end up with days wasted. It's very error prone having these different copies floating around. And sadly, it really discourages teamwork. And so a lot of modeling teams will, there will be like one person at a utility that is kind of the owner who has to do all of the data management. But no person is perfect, and everybody has blind spots. And then other people, they just don't really want to get involved because they know if they edit the model, then they have to worry about merging changes back and getting things validated. And so eventually, usually models will sit on a shelf and kind of collect dust. And then when the next master plan comes, the consultant will usually have to start from scratch and really overhaul everything. And it's kind of a costly process. So alternatively, what InfoWorks does is we store the model on a data server service that's running in the background on a data server. And so users can open the model. Edits are performed locally. It checks out a local copy. And so it will actually merge the changes with conflict resolution. So multiple people can be looking at and even editing the same model copy at the same time. And if there is actually a conflict where you argue over what the new diameter of a pipe is, a pop-up box will notice if two people manually enforce different values, which is pretty rare. And so this allows just a lot more collaboration. Different people have different viewpoints and different focuses and strengths, and so that can lead to better data over time. And of course, that can also result in a problem of having multiple cooks in the kitchen, is what I sometimes say. So the way we deal with that is having a full version history going back in time. So with that, you can click edit undo at any point if you're making changes, you don't like them. You can also go back in time before you hired that intern who broke your model, and model results are shared. And and an important layer on top of this is that every value can actually have its own data flag. So this is kind of just a GIF of the data with some data flags where blue is default values. We have GIS data. GIS never seems to have full coverage, so sometimes you have gaps in data, but your model needs to fill in those gaps in order to run. So you'll fill in the gaps, but you need to know which values you've filled in. And so you can flag those with maybe like a red color that says this is inferred, meaning it makes sense, it's logical, it's going to work, but it's not actually field verified. So come back and check it when you can. And sometimes you're updating things like head losses. And so here you can see as I edit this inferred value, it automatically tracks my initials so that you can know if someone set a really high roughness on a pipe, you can know that was done by John. You can actually see that it was done in November of 2020. So having that full version history is a piece of how your data can kind of keep getting better over time. So just one more GIF before soon I'll jump over the software. So this is just a workflow, a selected pipe in the plan, in the profile. Here its properties. You can see there's gaps in the GIS. There's a bunch of elevations are missing. There's also, we can see the data flags here, and it also will tell you where there are errors, like if there's certain values that are outside of the expected range, or if a value is missing that should not be missing. It's telling you need a value there. So here's just a simple example of applying an inference. So there's lots of tools to clean up this data and apply logic. So we apply the inference. It does some magic. Now it has invert elevations and head losses at all of those values, but it also applies the flag. So we'll see this happen one more time. So it also now flagged every value that it filled in, it flagged it as inferred so that we know we have to come back and fix that in the future when we get a chance. All right, I'm going to skip past that. A couple other things that I like about ICM just as a database for data management and cleanup is the themes. You can visualize data problems and you can really sift through the data visually pretty quickly and effectively with ICM. I actually prefer it over GIS tools, just because it is specifically built for water networks. There's SQL Queries, which is one of my favorite things. It was a water talk a few weeks ago. I have libraries of different SQL queries that can get you up and running, but these are your power tool to really sift through data. They can edit and even create objects in a bulk automated fashion. They're very powerful. You can also do direct scripting, which is using Ruby scripting, which takes it another level. And that's going to be what we'll talk about in that water talk on February 9th, I believe it was. So you can do direct scripting within the software. And then ICM Exchange is kind of the next level of the scripting, and this is an additional license, so it does cost money, but this is where you can run scripting from command line, so you can actually automate everything without even opening ICM. So you can have nightly scripts that run, at midnight every night that updates and rebuilds your model from scratch and validates and reports. So one utility actually does this, where on a nightly basis they update the model, rebuild it, audit it, simulate it, compare it with SCADA data, and export it. So you can kind of automate everything with ICM Exchange. This one does require an additional license, but these other ones are in the base of InfoWorks ICM. And it's this is also applied to WS Pro and Info Asset Manager. All right, and one last thing I'm going to show is that you can connect your ICM and SWM models with time series data. Typically you'll have a sensor network out in the field. It stores SCADA and telemetry data somewhere, maybe some kind of historian. And traditionally, modelers will have to request that data. You do a bunch of manual processing in Excel, and then you manually import it into event files in InfoWorks or your other modeling software of choice. And then you can simulate with it. And then next time a new event occurs, you have to restart the whole process. It's a little bit slow. I've seen some utilities even trying to do this with radar data, which is pretty a lot of work. Some workarounds. So that there's a module called Time Series Database. I believe actually, I think I may have seen that we're running an incentive program to make this more affordable for a little while. But the Time Series Database is in the ICM suite, and this can directly connect to your telemetry data and to radar data. So you can have it connected to your model once and for all, and then you can run radar data. You can have flow meters connected to actual pipes in your model, so that if you just choose the date range, it will automatically, or it'll auto map those comparisons. And so this cuts down a large chunk of the overhead to recalibrate your model, so you can actually keep your model kind of almost continuously updated. And this is really the stepping stone to go to real-time forecast modeling, which you can also do within InfoWorks. I should mention radar data. The time series database has been added for SWM networks. Radar data, not quite yet. I think that's coming out in an upcoming patch. If not, it'll definitely be in the May release. I think they ran into a roadblock with just the way SWM engine and IMP files requires rain gauge streams. And then if you have a feed for every single subcatchment, they just had to make, the developers had to come up with some workarounds to that. But that is coming out either in an upcoming patch or in May by the latest. All right, I'm gonna get out of PowerPoint and jump into some software. How are we doing on time? Sean, any questions we should pause to look at?
So we've got a couple questions so far that I think you'll cover eventually, but one of them is the computational engine behind ICM still SWM?
Oh, yeah. So here within InfoWorks ICM, you can buy ICM. It's just one license, but you get both the ICM SIM engine, which is our proprietary engine, that can do pipe networks, rivers, 2D, everything integrated, or you can choose to use EPA SWMM's engine. Full disclosure, it is a slightly modified InfoWorks SWMM engine. I'd have to follow up on the details of that. I know it uses a very recent, up-to-date EPA SWMM build, and we keep up to date anytime EPA SWMM releases a new SWMM engine. So we keep up to date, but we have a little bit of InfoWorks secret sauce on top of it, just to do a few necessary add-ons that we felt like we wanted to do, such as I'm drawing a blank on specifics. I feel like multiple soil types for infiltration on subcatchments, that you can do multiple dry weather flow loading on a single node, whereas EPA SWMM limits it. So just a few little additions there if you want to use it, but it should be compatible with EPA SWMM.
Bob Dickinson is saying that SWMM 5.1.015 is the ICM SWMM engine.
Okay, perfect. Thanks, Bob.
Yep. And reliable old Bob. Another question about a library of SQL queries.
Yes.
Is there any?
So that was one of the more popular water talks. We actually shared the recording with everybody, and it's racked up 200 views from GoToWebinar. So we can share that link if anyone asks for it in this chat. You can email me, or you can just put it in this chat and we can follow up.
I think this person wants access to an actual library of SQL.
Yeah.
An actual SQL library.
Yeah. One of the problems with ICM is that it's version specific. So I did create an ICMT of SQL queries, but on GitHub, I have an ICM Tools GitHub account that you can come and you can download any of these. So here I have different SQL queries, and you can copy and paste these into your InfoWorks environment. So I will paste this link into the chat. But yeah, there's some different tools in here, and it is gaining some traction within our internal side. There are a number of InfoWorks employees that do want to make a standard InfoWorks GitHub account where other users can contribute to an SQL and Ruby scripting repository. So hopefully that should be coming. I'm continuing to advocate for it. Let's see, I am putting that GitHub link into the chat, so anyone's able to go there and download any of the examples I've put together. Disclaimer though, don't go to the support team if any of those scripts don't work for you. It's kind of out there complimentary, but our support team does not know how my scripts work, and I'm not really in support. So use them at your own discretion. They're for example purposes. They're not guaranteed to work off the shelf for you. So yeah, let's see. All right, how about I'm going to run through a couple more things to show in ICM to get some of the things shown that I want to show, and then we'll jump back into questions.
Yeah, I think that's a good deal.
Yeah. So real quick, SWMM and ICM. So here is an ICM network, and here's a SWMM network. And so like if I select a node, for example, in an ICM network, it's asking for ICM fields like chamber floor and various things like that. Whereas if I select the same node in a SWMM network, now it's wanting fields that are specific to SWMM, like invert elevation, max depth. So so you can store models in either version, and it's going to expect the data a little bit differently, just so you know. So we store those a little bit differently. And so for now, I'm going to be doing everything with SWMM networks, but the same principles apply to ICM networks as well. So this is my SWMM network. We can have some different themes, or we can look at the data a few different ways. In this model, it's kind of a weird hybrid where we have subcatchment inflow. So it's like a combined system for a lot of the subcatchment, or for a lot of the catchment. This area down here uses RDII catchment areas. Here I have a theme based on the RDII catchment area. We can also do themes on pipe diameter. We can hide the nodes. Let's clear the pipes. We can take a look at pipe slopes. So you can create themes even based on a field that isn't stored in the database, but it will calculate expressions on the fly. There's really just a lot you can do with, it's buried behind. There's a lot you can do with these saved maps. I do recommend, if you do get into InfoWorks, to build yourself a little library of different maps, because that can be helpful just down the road. Let's go back to default, and I'm going to add some imagery in the background. And as you're working with data, I want to show those data flags and version control. So if we look at this pipe, for example, you can see these are the data flags, and a lot of the data came from SWM. So this model was created by importing from an EPA SWMM network. Some of the values were updated from GIS, and some actually has my initials. So an elevation was updated. You can actually drill into the full history of this pipe and see how it got these. So if I click on this pipe's history, you can see there have been 3 changes to this pipe over time. So version 1 and 3 and 6. So the network actually had multiple versions. I think this network is at version 8, but only 1, 3, and 6 was this pipe actually touched. And you can actually compare differences over time. So if I go to details, so if I go to previous, so this is version 1. This is what it looked like in version 1. By version 3, you can see the data is the same. It looks like someone added the data flags in version 3. If we go to next, you can see it's filtering out exactly what change happened. So it looks like a user with the data flag NG, that's me, updated the elevation, and you can see corrected flat upstream pipes. So you can actually drill into details on a specific pipe. You can also go to the full network. So there's been 9 versions, and you can see the number of changes, who made the change, their comments over time. And so this is really helpful. And you can do difference, and you can review the changes onto the screen, so you can see what things have changed. So you can track that version history over time, and you can track everything with data flags. The nice thing about the data flags is that you apply the flags as you're bringing in data and as you're making changes. So you don't actually have to manually set data flags. So for example, I'm going to import some new pipes real quick. Yeah, I'll just do it on the base network. So I'm going to go to Network Import, Open Data Import Center, and I can point at pipes. I can point at a pipe layer, which is Greenville pipes. So you can point at data. I'm going to go to pipes, swim. So you can load and save mapping between the source data and your model. You have different options to merge the data, overwrite the data, only update existing. But as you import, you can say this data, at any value I bring in and I fill in my database, make sure it tracks with a GIS flag. And you can also have default values. So if the conduit height is missing, maybe go to 99 and give it my initials. So as it imports, it's going to use conduit width as the conduit height. But if the GIS is missing that value, you can have your own default value that it will import, and you can also have a backup data flag so that you know to go back and review that. So you can do all this. You can save the mapping, and you go through and you import. What I actually like to do is you can actually, so everything you do with this interface here of importing and exchanging data with data flags, you can actually turn that all into a script that can go into a button. And so we'll do this, in that upcoming February 9th webinar. But I've rather than doing layer by layer, I wrote a script and it creates a user interface. The script is really easy. It's actually, there's examples out there. I'm sure Luke is gonna share one. You don't even have to actually be good at scripting. You just need an example, and then you just change the data path and a few options. But so here, let's say I want to import my pipes and I want to update my manholes. For my flag, I'll use GIS, and it's we're importing data. So I just kind of baked some of these options into my script and I turned it into a button. So if I click OK, it now imported my conduits and my nodes. And so actually, if I do undo again, you can see this is the little subdivision that I just imported. So it looked like it imported the pipes and then the nodes, but so there we go. We have these new pipes. Let's take a look at the data. This is kind of looking at what we saw in the GIF and the PowerPoint. So this is missing some data. We're missing some invert elevations. We can see the GIS flag where I've imported. Let's go ahead and just use a query to clean that up. I'll just stick with that query. So this query does different things like, like if we know one of the pipe inverts, the node is going to use the lowest connected pipe invert to use as the node invert, and so on and so forth. And we're going to assume, things where we need to assume it. But now, if we click on this pipe, for example, the script added, it filled in logical looking data, but it included that flag as it went. So let's see. So that's done. Let's see. Oh, and another thing is that we can also have scenarios. So so you can see here, if I zoom out, we have like existing Southwest branch. I have 2030 Southwest branch, 2040. We also have Northwest, and so on. So we have a library of different scenarios, and you can actually use queries to, let's say this is a new branch of pipes and I'm not actually fully sure what the diameter should be. Like maybe I'm still designing this set of pipes. So let's say I actually, this is my first guess, but I want to just create a dozen scenarios that it's going to try out different diameters, and I'm going to see what's the smallest diameter set I can get away with to achieve my design. So this is just a simple example, but if I open this pipe scenario loop, I just create a list of different diameters that I want to try. So 20 inches, 21, 22, 24, 26, up to 30 inches diameter. And it's just a while loop that's going to add scenarios, and it's going to update the selected pipes to use those diameters. It's just a simple example. You could do a lot more with it if you wanted, but if I click, actually before I click apply, let's look at, so these are the scenarios I have, and when I apply it and close, now I have these new scenarios down here. So if I go to 20, you can see the pipes just got smaller. So now they're 20 inch conduit height, 24, here's 28 inches. So you can have a quick query that's going to create a dozen different adaptations to your model, and then you can validate and batch run all these simulations, and so on. We can also write queries that will report out data between different scenarios. Sorry, I guess I'm I'm kind of going back into SQL just because it was a common topic. But really,
I've dropped the link to that webinar from a couple weeks ago in the chat window. So anybody who's looking for it can find it there.
Okay, thanks, Sean. Yeah, SQL is not required to be a data manager in ICM, but I find that there's so many tools that can make your life easier that I figured I couldn't talk about streamlined data management without a few like little tips and tools to help you. So this was just a query that will kind of sort out and report the total dry weather flow loading between different scenarios. So you can even write queries that will report values among different scenarios all at once. So you can see my existing has 185 gallons per minute commercial, whereas it goes up a little bit in 2030 and up a little more in 2040. So all right, so let's see. So we've talked through data flags, version control, etc. I actually didn't mean to add these pipes to my base scenario because now those pipes are in all my other scenarios, but I'm gonna validate. So one of the nice things about ICM is that you can, I'll also validate these two. You can bake in validation and it will check through your model for different things that you may or may not want to do, use in the model. So it will help you, spot common errors. And I'm remembering back to my plan. I didn't actually need to do that. So while that's validating, so it tells me the different warnings in the model. What I did want to show is once you commit your model and make changes, you can then run simulations. And so here I have all my different scenarios. You can run simulations, and another thing is that you can actually run simulations out on remote servers. So I'm going to run these 10 scenarios on any available computer. And so my laptop here is connected to a server in Denver. And so the upload and download speed is not very fast between Chicago and Denver, but you can see a bunch of these simulations happened on my laptop, some happened on Denver, and within a few seconds, these, I don't know, dozen or so scenarios are all done and ready for review. So that can be nice, being able to push out simulations remotely, especially if you're doing long-term simulations. And so where I'm going next is updating the model, data management. Now, let's say you have certain team members that don't have ICM. They need to use EPA SWM or some other swim modeling tool, or maybe you have contractors that are looking at building a development and they've done some EPA SWM models. So how does ICM interact with other swim models? So what you can do is now on any of these simulations, you can right click and export to SWM5. So this will put together the network, the scenario, all of the time series data. But you can also right click on the network itself and you go to export to EPA SWM. And so now I can choose any scenario that I want to export, and you can actually also go into the version history. So you can export a certain scenario from November of 2020 if you want. And so it really is a fully backed up library of swim models that you can push out to share with anybody as needed. I'm going to go with the latest, and I'm going to go to existing Southwest branch. I'm going to put this here. And now what I'm going to do is I'm going to actually import that model into EPA SWM. I'm going to make a couple changes, and I'm going to push the model back. So I just opened it up in EPA SWM. Just a couple warnings about supplementary data, not a big deal. But here is that network in EPA SWM. And now I'm going to endeavor to add a couple things and then merge those changes back. So there's a node. Here is a pipe that's going to connect here. And I'm going to edit some of that data. So this node, I'm going to call this new MH. Let's give it invert elevation of 730. I'll try to make this quick for everybody. So we'll give it 3 acres of sewer shed area, and we'll give it an RTK hydrograph. So it's got an invert. Let's give it a max depth I don't know, 10. All right, and let's also edit this pipe. So we'll call this new pipe with a 2-foot diameter, and we'll call that good. And let's do a couple other random changes. So this pipe, we'll need to upsize this pipe and this one to accommodate that new development maybe. This is just random hypothetical stuff. And we'll do some random changes. So there's a pipe up here that we're gonna update, and just a random pipe. Let's pick this one. All right, there we go. So those are a few random changes. I'm gonna save that. And so how would I bring this back into and then merge it with my centralized database? So what I would probably want to do if I were managing this database is, rather than trying to import it directly onto my version controlled model, I'm going to actually, let's see, I'm going to actually import it into my master database first, and that's where I can review it. So I'll just create a new model group, and here I will import that SWM file. So water talk. All right, it gives me a few notes. So this is that network that I just added. We can see the new pipe that I added. So I can review this model here, make sure everything checks out before I merge it into my master model if I wanted. And what I'm going to do here is, there's a few different ways to merge models. One way is you can actually do compare, and you can compare different networks, and you can actually push the changes to a CSV file, and that CSV file can also then update a model. So that's one way to merge changes. Another way, since I like the SQL approach, it's kind of a weird approach, but I'm going to actually just copy this data, and I'm going to dump it on top of this scenario. So this copy and paste objects is kind of a helpful tool. So I just dumped this model on top of this one, and I'm going to actually just drag a SQL query that just goes through each of those duplicate records. It tracks down any changes, applies data flags, it removes any replicas, and so it's processing through. It should be done right now. Okay, so that's interesting. I did it a little bit out of order. I wonder why this pipe didn't get that new diameter. What, didn't I update this one? Oh, this one is 22 still. Maybe I didn't save that change here. You know what? I think I closed this one, and it somehow didn't save that I changed this pipe diameter. But anyways, so this pipe was still the same, but it caught that this pipe has a new data flag. So it flagged that new diameter, and the flag that I used is that it's from SWM. And we also now have this new pipe that got added. So now I can validate this scenario, and what we find is that this pipe, we just need to re-snap it to the node. And I think it also didn't have the invert. Oh no, yep, it did have the invert elevations. So, oops, actually, yep, no, it didn't. So yeah, the SWM didn't actually store any invert elevations, but we can just drag this on and then have it detect those invert elevations, and now we can validate. So these objects that are still warnings are from this other segment that I imported. I didn't intend to import it into this scenario, but so that is a process of getting data out in between these two, and I ran over a little bit. So let's take a look at the question chat. I think that's all. That's almost all that I wanted to show with ICM. The last thing, real quick, is just integration of telemetry data. So you can connect to time series databases, and this time series database is right here. So this can be a repository that stores all of your measured data over time. So if I go to flow meter in the Northwest. This will store, years worth of flow meter data that is then accessible and available for you to use within your model, and you can have that connected to the model so that whenever you run this model, it will be integrated with this time series data. So like in this model, I have little symbols where there are flow meters. They're kind of coordinated with color-coded catchment basins. So each flow meter corresponds with a color. So if I click graph on this pipe with a flow meter, we can look at how the model's comparing to SCADA data for that period of time. And as I zoom in, you can also see the integrated volumes, how they compare. And so that can really streamline things when you kind of have the rain gauge pre-processing all mapped to your model and flow meters. And then that can also be a central aspect of your SWM model management. All right, so I'm done with my spiel. Let's take a look at some questions in the chat. Sorry, I ran a little long there. Yeah, Sean, any questions?
Sorry.
Focus on.
Couldn't get myself off of mute. So we've got a few questions around the different SWM versions and whether you can select the EPA SWM engine, not just the most recent or the one that Innovize has modified. So are there other SWM engines available?
To my awareness, Innovize has gone the approach of maintaining our own version of a SWM model that keeps up to date, but it's other software. I think you can pick any version of SWM and use that, and there are trade-offs. There are pros and cons with that approach. Our advantage is that we have the liberty to add things like in because we also do drainage design. I know we've put in 1D green infrastructure into the hydraulics side of the engine with SWM for one part of our software portfolio. So like we're maintaining some of our own local in-house additions.
Got a question about the GUI for ICM, and maybe you don't know about our roadmap for this, but is there a plan to transition to a ribbon style GUI versus?
There is actually a user voice request on that. It's been heavily requested among ICM users to be able to use ICM on multiple monitors and break out of this framework that we've been tied to. This is kind of rooted into the foundation of ICM. So it's on there. It is under discussion because it would require, gosh, sorry, I don't recall exactly where it is. If I could maybe sort by popularity, but yeah, there is one on here that's overhauling the InfoWorks UI. It has a lot of votes. If you want that, go ahead and vote there. But yeah, I know that we're looking at that, but it would require a few months of development that would have to sideline our other features.
It's always such an issue too, because half of the users would probably be really excited for the update of the GUI, and the other ones would be like, "Where's this button? Why did you move it? I've used it there for 15 years."
Yeah, it would require kind of a reassembly of ICM, unfortunately.
Yeah. Question from Jamie: would using ICM for SWM allow the user to use the SWM groundwater and aquifer routines?
Yeah, I have not gotten into SWM modeling of close all tabs. That should all be available. So if I go to the subcatchments is where I would expect to find it. Yeah, so you can set up the aquifer data, soil porosity, conductivity, and so on, and have that associated with subcatchments. So yeah, we didn't talk. I didn't go into some of those details, but yeah, here is groundwater parameters that you can set on subcatchments. So yes, you could
Great.
do that.
Another question from Bailey saying, I'm aware of the find and replace flag feature, but is there a way to find flags throughout the model without replacing that flag?
Well, yeah. One of my approaches is using SQL queries. So let me see. I did one recently. So like for instance, if I know that my invert flags should always be GIS, you can write queries like this that's going to select all of the pipes where either one of those is not GIS. So if I click apply here, these are all of the pipes in my model where GIS did not give it one of the inverts. So if I click on this pipe, for example, it has the downstream, but it doesn't have the upstream elevation. So user ng populated that. So I don't think there's a software baked in UI for that, but queries can help you select and find those pretty well.
Another good place for another good topic for the user voice, maybe.
Yeah.
If that's a topic that's important to you. Is there a way to export the data quality, so the flags from ICM back to SWM? So are the flags transmitting between the SWM and ICM?
Not to SWM that I'm aware of, just because SWM, it doesn't really store supplemental data, but the flags themselves can definitely be pushed and shared back to GIS, for example. So like if I'm pushing out links to a shapefile, or it's probably not gonna like that as a shapefile, but if I add a couple rows, I can do fields. You can actually export the fields with all of the flags. So you can export out flags as fields in a shapefile or your GIS layer. So that can be a good way to share back with your GIS team any places where you didn't like their data and you you deviated. But yeah, as far as actual SWM files, we just export the IMP, which just has like the pure hydraulic data.
Cool, great. Got a person asking for a copy of your merge SQL. Is that in your GitHub by chance?
It is not, but yeah, I can upload it.
Okay.
Yeah. Yep.
Let's see.
I see a comment about one of my pipe diameters. I entered 3 feet and then it got to be 35.9999999 inches.
Yeah.
So that's something unique to ICM. So ICM, it's developed in the UK, it's used around the world, and behind the scenes, it does everything in SI units. And this actually is really nice in a lot of aspects, but for us US users, I tell it it's 22 inches. It still tells me, yeah, it's 22 inches, but behind the scenes, it stored some value in millimeters. And so sometimes you get these slight rounding errors. Now, what actually happens in EPA SWM, I'm not sure. I believe that those end up getting rounded out because it does that with, probably way too many orders of accuracy, as if you really knew the exact precise diameter. But yeah, there are slight rounding issues that happen within ICM because throughout the data, units are a very relative term. It stores everything in the native units, and you can have some people editing the model in CFS, other people can be modeling the model or editing the model in GPM. It's going to merge everything in the same language. So in a lot of ways, that's nice. It does all of the translations in and out for you, but that is one downside. So when you click on these, it gives you this 7.9s afterwards.
Yeah. So we're closing in on time. So if you have to leave, I want to thank you all for coming. But Nathan, you want to do answer one more?
Yeah, I'm just sifting through.
So, one person has a question. When you're transferring between ICM and EPA SWMM, is the time series data carried over automatically?
So yes, if you're using the event files, like if I when I export, it's going to include like these rainfall event files when I export from a simulation. However, I did notice last night in my testing that if you're using the full time series database integration of sensor data, it didn't look like that gets exported, but I'm sure that we released that a couple months ago, and I'm sure that should be coming. I already sent a message to product managers that should be integrated, so you can have an ecosystem of, I don't know, some cities may have like 36 rain gauges, so it would do all of that rain gauge processing from raw data to 15-minute averages, and then you just have it do all of the heavy lifting, and you just export it out, and everything is all mapped for you, including potentially radar data down the road, which could be really cool, where ICM would do all of your radar data overlays, and then you can even run that in EPA SWMM if you wanted, because it's done all the mapping for you.
Awesome.
All right, we are over time. Thank you everyone for attending.
Yes, thank you very much. Don't forget to sign up for the upcoming water talks. Those should be announced, and we'll hit you with some emails to come register. So see you all soon. Thank you very much.
All right. Yep. Bye, everyone.